In example 10.6, we're going to start talking about reasoning in algebra and geometry. So you don't need to write any of these directions down, but I want you to write this down somewhere in your notes or in the solve it area at the top of your page on page 629. Follow the steps of the brain teaser using your age. Then try it using a family member's age. And then I want you to see if you notice something. So here are the steps. Write down your age. Multiply that age by 10. Now add 8 to the product. Okay, now double it. Subtract 16. And then take your result and divide it by 2. Follow those same steps with a family member's age, and I want you to notice something that happens. If you do that, you should notice that what you end up with is the product of your age, or your family member's age, and 10. So, while I can't show you that the brain teaser will always work by using numerical values, what I can show is that it will always work if we use the value of x as the age. So we're going to start by writing down the age as x. We're going to multiply that by 10. Then we're going to add 8, so 10x plus 8. We're going to double that, so I'm going to times all that by 2. That gives me 20x plus 16. Subtract 16, so I'm left with 20x. Divide that result by 2, and I'm left with 10x. So x is the age that we started with, and our final answer is always going to be 10 times that. In the middle of the page, on page 629, in the gray box, it says, in the Solve It, you logically examined a series of steps. In this lesson, you will apply logical reasoning to algebraic and geometric situations. Here's your essential understanding. Algebraic properties of equality are used in geometry. They will help you solve problems and justify each step you take. In geometry, you accept postulates and properties as true. Some of the properties that you accept as true are the properties of equality from algebra. So if you look at your key concept, all of the properties that are not in bold are all ones you've done before. So if you look at what it says, it shows first that a, b, and c can be any real numbers. But the addition property is when you can add something to both sides. Now, you've used these when you solve equations, which you've done since elementary school. But the addition property is when you take something and add the same number to both sides. Subtraction is subtracting something from both sides. Multiplication is by multiplying something by both sides. And division is by dividing both sides by the same number. Now, these are new. Reflexive property is when something equals itself. The symmetric property is when you let A equals B, then B equals A. Transitive property says that if A equals B and B equals C, then A will equal C. And substitution property states that if A equals B, then you can take B and replace A in any expression. At the top of page 630, you will notice the next key concept, which you've already done, the distributive property. I'm not going to go over that. You've done it before. Just look over it. It's stuff that you've already done. Above problem 1, it says that you can use deductive reasoning when you solve an equation. You can justify each step with a postulate, a property, or a definition. For example, you can use the distributive property to justify combining like terms. If you think of the distributive property of AB plus AC equals A times the quantity B plus C, or AB plus AC equals B plus C and then all of that times A, then 2x plus x is the same as 2 plus 1, x, and then equals 3x. So we're going to go over problem 1. You do not need to write this down if you do not want to, but just watch. In problem 1, we want to find the value of x, and then we have to justify each step. So this is where it's going to be a little tricky, because this is going to be hard because you're going to start a proof. So if you start a proof, we first have to look at this problem and see what can I do. Well, the equation itself is easy because you know that these two angles are a linear pair, or they form a straight line, which means they're supplementary. They add up to 180 degrees. So the first thing we have to do is we have to actually write down that the measure of angle AOM and the measure of angle MOC equals 180. And we have to justify that. Now, you have two options to do this. You can either do the work and then the definition, or the justification, or just solve it all first and then write down the reasons. So the first thing I'm going to do is just go through and solve it. So the first thing I'm going to do is I'm going to substitute in what AOM is. The measure of angle AOM is 2x plus 30. The measure of angle MOC is x, and we know that equals 180. I combine like terms, that's 3x plus 30 equals 180. I subtract 30 on both sides, and you can show me those steps if you want. Subtract 30, that gives me 3x equals 150. And then I divide by 3, that gives me x equals 50. So we know x equals 50, but now we have to go through and justify each step. So the first thing is that we know by the definition of supplementary angles that we can set up our equation. Now notice I am completely abbreviating, which is fine. You'll notice a lot when you do proofs that you can abbreviate a lot of your reasons. So the definition of supplementary angles. The next thing I did is I substituted in what the measures of those angles were. So I used the substitution property. The next thing is I combine like terms. Combining like terms is almost like undistributing, so we did use distributive property there. I then subtracted 30 on both sides, and subtracting 30 on both sides is called the subtraction property of equality. And lastly, I divided both sides by 3, which is the division property of equality. So on the left is all of your work to show that x equals 50, and on the right is your justification. So let's look at the got it problem. The got it problem says, what is the value of x? Justify each step. We know that ray AB bisects angle RAN. So the first thing we're going to do is we're going to write the measure of angle RAB equals the measure of angle BAN. And why do we know that? We know that because the definition of an angle bisector. Because the definition of an angle bisector proves that two angles are equal to each other. And remember, you can use definitions as your justifications. So the next thing I'm going to do is say that x equals 2x minus 75. What's the reason? Substitution. We can put property. I now subtract 2x on both sides. So if I subtract 2x, that gives me negative x equals negative 75. I just used the subtraction property of equality. I now divide both sides by negative 1. X equals 75. And I used, by dividing both sides by negative 1, I used the division property of equality. We're now going to do number 1 under the practice problem on page 630. I'm not going to write this down because it's all given to you. You just have to fill in the blank. So pause the video if you want and see if you can figure out the 3 blanks about the reasons that justify each step. So if you look at number 1, you're given the equation 1/2 x minus 5 equals 10. What do they do in step A? They multiply both sides by 2. So that would be the multiplication property of equality. So A would be the multiplication property of equality. Then they distributed the 2 times 1/2 x minus 5, and that gave them x minus 10. So B would be distributive property. Then the last step is adding 10 to both sides, and that would be the addition property of equality. Our next key concept is in the middle of the page 631, and it's called properties of congruence. Now, if you're not royally confused yet by the video, this will make it even harder. So, your key concepts of properties of congruence. You have 3 things: reflexive property, symmetric property, and transitive property. The reflexive property shows that 2 segments are congruent and 2 angles are congruent, but both those segments or angles would be the exact same thing. So AB is congruent to itself, and angle A is congruent to itself. So segments and angles can be congruent to itself. Symmetric property states this: if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. You can flip them. The same thing is true for angles. In the transitive property, we can say that if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. The same thing is true for angles. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. It's kind of like what you just learned on the first key concept, but instead of actual values of like A and B, we now have segments and angles and congruency. All right, so let's look at problem 2, using properties of equality and congruence. So we're on the got it problem. In the got it problem, it says, for parts A through C, what is the name of the property of equality or congruence that justifies going from the first statement to the second statement? Now remember that on the first set of key concepts on page 629, those were properties of equality because things are equal to each other. In the middle of the page on page 631, you're talking about properties of congruent because segments and angles are congruent to each other. So A says segment AR is congruent to segment TY. And then segment TY is congruent to segment AR. So you'll notice that these segments, we're just reversing them and saying that they're congruent. This would be the symmetric property of congruence. Now, I'm just going to write this. Of congruence. B, you have 3 times x plus 5. And on the next step, you get 3x plus 15 equals 9. This one's pretty easy. This is the distributive property. C, 1/4 x equals 7. And you get x equals 28, which means both sides are multiplied by 4. So this would be the multiplication property of equality. And you could just abbreviate by EQ. D says, what property justifies the statement the measure of angle R equals the measure of angle R? Now you got to be careful here because we have 2 reflexive properties. Reflexive properties obviously state 2 things are equal. But reflexive property of equality is when the measures are equal. Reflexive property of congruence is when 2 things are congruent. So D would be, I'm going to put it at the top here, the reflexive property of equality. All right, and if you haven't had enough fun yet, Turn to page 632, and this is the start of a proof. Vocab word. A proof is a convincing argument that uses deductive reasoning. A proof logically shows why a conjecture is true. A two-column proof lists each statement on the left. The justification or the reason for each statement is on the right. Each statement must follow logically from steps before it. The diagram below shows the setup for a two-column proof. You will find the complete proof in problem 3. You must always have it set up just like that. The given, what you need to prove, and the diagram. And then underneath, you're going to have a two-column proof where the left says statements, the right says reason, and the first steps are always the given, and the last thing is always what you need to prove. So I've recopied the given and the proof in the diagram, and so now we need to make our two-column proof. So we start with our given. The measure of angle 1 is equal to the measure of angle 3. That is the given. You have to prove everything. And let's look at what we have to prove. We have to prove that the measure of angle AEC, that would be these two together, is going to be equal to the measure of angle DEB, which is these two. Now, I'm going to tell you right now, the hardest part of a proof is knowing where to even go and what you need to do. But you have to take it one step at a time and understanding what you're doing. So we're going to look at what we need to do next in the way of proving that 1 and 2 is equal to 2 and 3. Well, obviously we have to look at 2. So our second step is going to prove that the measure of angle 2 is equal to itself. Because we have to prove, we're going to use it twice, we have to prove that it's equal to itself. What do we use when two things are equal? We use the reflexive property of equality. Remember, we have to have equal sign here, so it's equality, not congruence. So remember, this is like our equation. The measure of angle 2 equals the measure of angle 2. I now am going to take the measure of angle 1 and add the measure of angle 2, which is equal to the measure of angle 3 plus the measure of angle 2. Now let's look at what we just did. Up here, we already are saying in our given that 1 and 3 are equal. I said in the second statement that the measure of angle 2 is equal to itself. I now am taking my given and I am adding the measure of angle 2 on both sides. Now I can do that because I proved that they are equal. So now I'm taking my step 1, adding the measure of angle 2 on both sides. What am I using? Well, if you add something on both sides, this is the addition property of equality. Step 4. Now, here's the next problem. You guys have already used from geometry postulates. They are in the back of your book at Z1. So if you turn back in the glossary, it's right before the glossary in Z1. You've already learned something called the angle addition postulate. The angle addition postulate, if you're looking at Z1, states that if point B is in the interior of angle AOC, which basically means you have a point B that's in the middle of an angle, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. It's two angles added together, which is what we're doing here. We are adding 1 and 2 together to get the angle that represents. So we have to take the measure of angle 1 plus the measure of angle 2. We just added two angles together. That gives us the measure of angle AEC. The measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. We just did the angle addition postulate. We added two angles together to give us the measure of another angle. So we used the angle addition postulate. Now, we can say the measure of angle AEC is equal to the measure of angle DEB. Why can we say that? We can say that, and that's what we're proving, because of substitution property. I substituted right here. I said that these two are equal to this. So look at what I did. Here's my statement. I took the measure of angle 1 plus the measure of angle 2 and substituted this in for it. I took the measure of angle 3 plus the measure of angle 2 and I substituted this in for it. Notice that 1, 3, and 5 are like a continuing equation. But in there, 2 and 4, I had to prove things first before I kept going. This is going to be difficult. And I know it's going to take practice, but just keep working through it, keep asking questions, and keep studying. So what I want you to do is to attempt the got it problem. I don't care if you don't get it. I don't care if you have, like, you get struggled or you get stressed out on it. I want you to just try it. If you don't get it, no big deal. We will do it in class. But I want you to at least try it. You can at least set it up and do your step 1 and your last step because you know you're given and what you need to prove. Also, there's a lot of vocab words, there's a lot of properties, there's a lot of postulates. You must memorize them all.